In a recent mobile app testing survey, 84% of QA organizations said they need to test on real devices in order to be successful. Cambrionics builds managed USB hubs to help you test easier. Discover how managed USB hubs can accelerate delivery of your apps. Learn more at cambrionics.com.
So you need to build a deep learning model for something like image or text classification. What if you could homebrew install a package and then from the command line, call an executable, pass in a CSV file, some JSON config parameters for the input and the output, and what you get is a TensorFlow trained model with an accuracy in the 90th percentile range. Would that interest you? Piero Molino is a senior ML NLP research scientist at Uber AI Labs and is working on a project to do exactly this. Open sourced in February of this year, Ludwig is a code-free deep learning toolbox built on top of TensorFlow that can be used to build experiments by technical and non-technical staff around things like NLP, vision, question answering, categorization, and more. Hi, my name is Wes Reisz, and I'm one of the hosts of the InfoQ podcast. In addition to hosting the podcast, I also chair a set of software conferences called QCon. QCon New York is next up, June 24th through 26th. Hope you can join us. Piero, who we're talking to today, gave a presentation at QCon AI, which was just recently held in the Bay Area, about Ludwig. And it impressed me so much, I wanted to do a podcast in the podcast format to kind of talk a bit about Ludwig and kind of share it in this audio format. So today on the show, we're jumping into this discussion to talk more about the use cases of Ludwig and what you can do with it. So Piero, welcome to the show.
Well, thank you, Wes. Thank you for having me.
Absolutely. So first off, you work for Uber AI. Let's start off there. What's the mission, the purpose of Uber AI?
Sure. So Uber AI basically is the research and platform team regarding everything AI in the company. The only thing that we don't do is actually self-driving cars. There's a different organization in the company called ATG that does exactly that. And so that's basically the only thing that we don't do, even if we have some collaborations with them. And there's basically, I think, 5 teams at the moment in Uber AI. One is like a co-research team. The goal of that team is to write papers, having like a presence at conferences and publishing things and being part of the research community mostly. And then there is like a team that we call Connections team, which is a team of applied AI and machine learning projects. They work with other teams at Uber, other product teams, and they help them out figuring out like the best way to run an experiment, the best models and the best parameters of their models. And this is actually really important for the company because, I mean, in many cases, having an optimal model or a more optimal model makes for huge savings or in general can have an impact on the bottom line. And then there are other 3 teams that are specific to specific areas of machine learning. So there's a team that I work in specifically, which is conversational AI. And we are building a platform that can be used by different other teams for having conversational capabilities added to the Uber app, to the customer support, and so on. And then there's also a computer vision team and a team that works mostly on, it's called sensing and perception, works mostly on sensor data and how to learn from sensor data, in particular in an unsupervised way.
Through the projects that you're working on, you released February 21st, Ludwig. And Ludwig is a code-free deep learning toolbox that's built on top of TensorFlow. What does a code-free deep learning toolbox? Those things don't go together for me. They don't fit together. When I think about TensorFlow, I don't think about code-free. So what does that mean?
So I see like how someone could be confused by the idea. So the main point is that what I made is so that you can specify a TensorFlow model in a form which is much more digestible. It's just a configuration file. It's like in a declarative format where you specify what are your inputs and what are your outputs. And depending on that, Ludwig builds a TensorFlow model that can deal with those types of inputs and those types of outputs without you having to explicitly specify how that is done, actually. And so once Ludwig builds this model, also can train it and can use it once it's trained for obtaining predictions. It's code-free, but that doesn't mean that you cannot actually change the behavior. It's really extensible, but at the same time has a programmatic API that allows you to train models in a really, really simple way. You just need a couple lines of code, one for saying model.train and the other one is model.predict. And that's all you need for training and predicting a model.
So, how many things can this really do? I mean, is this just classifying cats, or how deep can we go with Ludwig?
My opinion is the main strength of Ludwig is an abstraction that I built, which is based on the data types. And so there's, in theory, limitless amount of things that Ludwig can do because you can specify the data type of your inputs and the data type of your outputs. And depending on the combination of those data types, all sorts of applications can be done. So for instance, one of your inputs could be an image, right? And one of your outputs is a category, and then you can build an image classifier. But if your input is text and your output is a category, then you have a text classifier. But if your input is, for instance, an image and another input is a text, where you have, for instance, an image and a question about the image. Is there a dog in this image? Or what is the color of the hydrant in this image? And then the output is, again, a piece of text. Then you can have a question answering system where you can ask questions about an image and obtain text as output answering the question. So basically, the whole combination of all the input data types and all the output data types makes for potentially an infinite amount of applications. But that's also a weakness to a certain extent, because it means that in order to provide a specific type of functionality, one needs to provide that specific data type for the users. And so Ludwig at the moment covers many data types as text, images, time series, sequences, categories, binary values, numerical values. But for instance, at the moment, it doesn't support speech. And so at the moment, you cannot do speech recognizer, but there's nothing like stopping us from adding it. So it's just a matter of time, and more data types will be covered. And so with Ludwig will be possible to have also speech recognizers and other sort of models that at the moment you cannot do because the data types are not available yet.
So let's walk through maybe an example. Say I want to do a text summarization or something with Ludwig. Walk me through what it would take me from, say, I'm on my MacBook here and I want to get Ludwig on my box, and then I need to take some corpus of text to be able to train this and then be able to run it. What do I need to do? What types of things do I need to think about? How does this all work?
Text summarization, usually it's like in literature, a couple types of text summarization systems. One is called abstractive, the other one is extractive. The extractive ones is like selecting pieces of a text that are going to end up in the summary. The abstractive is the type where you actually have to invent, to a certain extent, new text, which may not be present in the original text. So for simplicity, let me give you an example of how you would go and do the extractive, because it's kind of a little simpler. So one way you could do that is you can have your input CSV, which contains a couple columns. One is your input document, and the other column is a sequence of 1 and 0s. And those 1 and 0s could basically represent, should this token or should this sentence appear in the summary? 1 means yes and 0 means no. And so then what you can do with Ludwig, you can specify this file as your input data. And then you can specify a model definition that contains one input feature of type text and one output feature of type sequence. And Ludwig will learn to, given the text, predict that sequence of 1 and 0s. And so from that sequence of 1 and 0s, when you have a new data point, a new piece of text, then Ludwig will predict 1 and 0s. And so from those 1 and 0s, you can select the parts of the input that will end up being the summary. And the only caveat there is that you have to specify the output sequence to be a tagger. So you have to specify the output to be a tagger, which basically means, so for sequence decoders, this is actually a nice feature of Ludwig. For both inputs and outputs, it can have different encoders and different decoders. So for instance, for text, you can have one encoder, which is LSTM, another encoder, which is a CNN, another encoder, which is a transformer. These are all different models that can be used for encoding text, and the user can select them, just providing the name of the encoder that they want to use. And the same applies for the outputs. For sequential outputs, there's generator, which basically generates text token by token, and a tagger, which is slightly different. It takes all the inputs and classifies each single input. In this case, for the text summarization example that we were following, it would classify each single element of the input, being it either a sentence or a specific token, to be 1 or 0. And so the length of the input sequence and the length of the output sequence are perfectly aligned. That's why you can use a tagger.
And then how much data do you need to give it to actually train it?
That really depends on the task. There are some rules of thumb that usually people try to follow with deep learning models, because usually deep learning models are kind of data hungry. Thumb is, for instance, if you have a classification problem, the rule of thumb is that you want to have at least 1,000 data points for each class. You could do well with less data if your classes are, for instance, pretty well separated between each other. But again, this is just a rule of thumb. It really depends on the specifics of your use case.
Yeah, very awesome. So what are some of the use cases that are being used in Uber with Ludwig or outside of Uber for that matter?
As I basically started building this thing for myself while I was doing one specific project. And so this project was a customer support model called Kota. And there's both a blog post and paper that we published at KDD last year about it, if you're interested in more details about it. And so this project was basically, we wanted to provide to customer support representatives suggestions on what kind of classification of each single ticket that was coming this specific ticket belonged to, and what was the best answer template to use for answering this ticket. And so at the beginning, I just built a model for doing that. Actually, two models, one for each of those tasks. Then new features came in particular related to specific trips. So for instance, at the beginning, I only had the piece of text that the user was sending us. Then I also had additional information like, was the trip that the user is complaining about, like completed or not? How much did the user pay for that? How long was it? And so on. So I had these additional features. And instead of making it so that it was a one-off thing, I made it so that you can generically add a categorical feature, you can generically add numerical feature, and so on. And on the other hand, I made it so that the same model can be used for doing both tasks because they are really related to each other, right? If you know what type of ticket this is, you also probably have a better idea of what you want to answer to this ticket, right? And so this is how I built it. And basically, Ludwig is the generalization of this package that I built for this specific problem. So this was the first application in the company of Ludwig. Now it has been used for many other things, in particular in conversational AI. We're using it for both language understanding, language generation, and also keeping track of the dialogue state. It has also been used for matching questions to questions that are asked on Stack Overflow within our chat. So you have this little bot that actually looks for similar questions on Stack Overflow so that if you ask something on a chat, it directly gives you the right answer. And there's actually a bunch of other use cases that have been used to, for instance, in Uber Eats for predicting expected time of delivery of dishes. And there are also new projects that are currently being built around Ludwig, some of them on computer vision, some of them on Uber Eats, some others are around all sorts of problems regarding Uber's marketplace, like expected time of arrival of cars, and potentially in the future also for pricing, all sorts of things actually. While for the external uses, the ones that I'm aware of, because there's probably many more that I'm not aware of, but the ones I'm aware of, so Ludwig is being used at Apple, I know that for sure, because they integrated it in their own stack of tools that they provide to their data scientists. And it has also been used for specific problems inside a couple startups. It is used by a company that is analyzing music lyrics. And so I don't know exactly what they're using it for, but I know that they're probably classifying lyrics and also assigning some labels related to some factors like sentiment or other measures of subjective feelings regarding the lyrics and the music. And I know that it's been used also for some forecasting tasks, in particular for prediction of stock markets. I know that people doing that, and also for forecasting for sport, to predict, in particular, for hockey and basketball. I know people using it for predicting things related to both the outcomes of games, but also more detailed statistics about sports.
That's incredible. So tell me, what type of accuracy are you seeing with Ludwig?
There is nothing specific in Ludwig, actually, that makes models good or bad. Like, it really depends on the models, right? So Ludwig is actually more of a structure that allows for some models to be used. So it really depends on the models that people are using for their tasks and on the data that people use for training the models. All my experiments so far, the models that you can train with Ludwig on the datasets that I've tested so far, which are like openly available datasets, Ludwig is always in the ballpark of the state of the art within a 1% margin, depending on the specific tasks. So you could potentially get even better performance if you were to spend a lot of effort making your own super custom model for the specific use case. But to get there, it will take you a long time. While with Ludwig, you don't have to do anything to get a really good model already. And plus, if you have this super custom model that actually gets this amount of performance, you could actually contribute it back and add it among the different options that Ludwig has available so that the next time you can reuse it for your new tasks.
Some of the questions that come to my mind, and I think you've already touched on it a little bit, is how extensible is it? How can I get in and kind of update what's happening under the covers? And then also things like algorithmic transparency and understanding how decisions are made inside of it. Is it just building on, what TensorFlow already has available, or does it do anything else, for example, on transparency? So a couple questions there. So let's start off with the transparency question. Is it just what's normally available with TensorFlow, or is there other things that kind of enable algorithmic transparency?
So regarding the algorithm itself, deep learning models are kind of a black box, and there are some approaches like Lime and CHAP that allow you to do some, let's say, local linear approximation of what actually is the decision-making process that happens for specific data points. There is nothing specific in Ludwig that supports that. The predictions of your model would be really beneficial, so it's something that we want to add in the future. But what is already there is visualizations that are useful for analyzing the predictions that the model makes and also the quality of the prediction that the model makes. So when you train a Ludwig model, what you're training is actually a TensorFlow model, and so there's the tensor board available to you with all the metrics that are tracked during training. Plus also you can look at the graph itself, like classical TensorFlow things. But on top of that, Ludwig also provides a bunch of visualizations. I think, I don't remember exactly the number, I think it's like 15 or so different visualizations. You just take the outputs of the Ludwig training process or the Ludwig prediction process, and from those outputs, you can have all these visualizations that allow you to, for instance, compare models on multiple metrics, look at how the models are calibrated, try to impose, like, for instance, thresholds on the confidence of the model, and see on how many data points can you obtain predictions with a certain amount of accuracy. So, for instance, you increase the threshold, decrease the coverage, but increase the accuracy. Or you can also compare the predictions of two models. You can see, given a specific data set, on how many of those data points in that data set the models are giving you the same predictions or different predictions, and when those predictions are right or wrong, so that you can analyze what makes two models different.
What truly affects the output?
Yeah, definitely. And so in general, all these visualizations give you more understanding and more confidence on the model predictions, even if you cannot really see what's going on in the model inside, because that's a different set of problems.
Now, what about extensible? You mentioned that Ludwig's super extensible. What do you mean by being extensible?
Obviously, it's open source, so people can go in the wild, can go on GitHub and look at the code and change it and play around with it. But we tried to make it really easy to extend it, in particular in two ways. We actually wrote this developer's guide, which is still in its infancy, but probably already gives some help to people that want to extend Ludwig. And so the two ways that we made it simple to extend is, first of all, given a specific data type, let's say text, right? It's really easy to add additional encoders for text, because all a user has to do to add an additional encoder, for instance, there's a new paper published on encoding text, and you want to add this latest and greatest model, all you have to do is conform to a really lightweight interface. And so this interface is basically, you can specify the upper parameters of your model as input parameters, and then you get a tensor in a specific shape. Specifically will be batch size times length of the text. And what you have to provide is a tensor with a specific shape, again, which is batch size times length of the text times hidden dimension. And whatever piece of code you put inside to implement this interface anything goes, right? That's why we have RNNs, CNNs, transformers, because they all conform to this interface. And so if there's a new model, it's really easy to add an additional model if it conforms with this interface. That's one way. And so that applies to every other data type, actually. That's one way to extend Ludwig. The other way to extend Ludwig is actually add new data types. This is a little bit more complicated, but still relatively simple, because what we provide is one class for input features and one class for output features with a bunch of interfaces that the user has to implement. Those are really simple. One is like an interface that maps data from raw data into tensors. And another interface is how to compute the loss for this specific data type. And another interface is how to compute the predictions for this data type. So those are really reasonable things that you would implement anyway if you had to implement something from scratch. We'll just provide a way to organize them that makes it more simple to you. And once you provide all these functions, then all the rest of the infrastructure of Ludwig, all the pre-processing, all the training loop, all the model construction comes for free. So I believe that it's great also for companies that don't want to create technical debt. Because once you, for instance, if you want to create a speech recognizer, right, you can add it to Ludwig, and then anywhere you will find a speech problem that you want to train a model on, then you can use it with Ludwig for free. And so it's a way around technical debt also, and good for code reuse.
So you released in February. How many contributors do you have? What's the community look like around Ludwig right now?
So there are two, main contributors apart from myself. Both work for Uber. One is Jarek and one is Sai, and I wanted to do a shout out to them. And they're helping me a lot. They're great. In particular, Sai did most of the work on testing, which obviously was super needed for code quality. And Jarek helped me a lot with some of the input features and also some of the organization of the code, so that now it's much cleaner than it was. Actually, we did this work before release, so it was much dirtier before, and after his help became much cleaner, much better organized. But apart from them, there's been a bunch of contributions from outside, some of them from other companies, like from CometML. They actually contributed integration with their own platform. So when you train Ludwig models, you can keep track of the trained models and all the statistics and everything on CometML, which is pretty handy because then you have an easy way to compare models and select the ones that perform the best. And then there's been a lot of contributions on improvement of the documentation. That has been pretty great to see. And code-wise, so far, people contributed many bug fixes, which is great. Not so much new features, but I think it's reasonable because it's a new project and people have to get used to it first as a user and then gradually also potentially as a developer. So I think we're still in the user phase, let's say.
Sure. We were talking about this just before we started recording, but it can be kind of intimidating to get involved in contributing to an open source project, particularly in the ML and AI spaces. What does it look like to kind of onboard new contributors? What does it look like to start contributing to Ludwig?
So we have many open issues on GitHub, like the vast majority of them are feature requests. And some of those are pretty simple, actually. And the reason why we haven't addressed them is just a matter of prioritization, really, right? And so starting to contribute to Ludwig would be simple because there are some issues, some open feature requests. They could be really simple and a really nice way to get started without having to understand every single little nitty-gritty detail of the code base. And also we provide support, and if people are interested in contributing, they just have to reach out directly to me, Sai, and Jarek, and we can direct you in the right direction for contributing on those simpler issues and then gradually get more accustomed to the code base. I have an example for that. So I recently went to Sofia for the Uber Open Source Summit, and one engineer, Sofia, actually reached out to me. And so now he's contributing on the visualization side of things because there are some missing features, like people want to have the visualizations in their Jupyter notebooks, but at the moment Ludwig doesn't support that because Ludwig opens windows with the visualizations. And so he's working on that, and we've been interacting really fruitfully so far. And it wasn't that difficult for him to get on board. So I would encourage people to give it a try. It's not that difficult.
So I'm assuming GitHub/Ludwig. Where can we find it?
GitHub/Uber/Ludwig.
Uber/Ludwig.
That's where you find the code and like the open issues. And there's also Ludwig.ai, which is the website with all the documentation. And there's also a GitQ forum for people to chat if they want about specific things for Ludwig, even if so far I haven't done a good job at advertising it. It's not really much populated. On the contrary, GitHub issues are much more populated as a way to exchange information.
Before we wrap up, Piero, what's on the roadmap? What are the next major things? I'm sure you're talking about new data types that you're going to focus on, but what are some of the big things that you have planned for Ludwig going forward?
Yeah, so I think there's a lot of ideas, a lot of new features that we want to add, but there are two main things that are the ones that we are currently focusing on. And one is, as you said, new encoders and new data types. So there are these relatively new state-of-the-art models in NLP in particular, like BERT and GPT, and we want to have them as options for the users to select, and also to use pre-trained models, which are pretty powerful. They've been shown to be really useful in many, many applications in the literature. But the same applies also for images and the other data types. So we want to add many more encoders. We also want to have more data types. As I said, that we want to have speech, potentially also videos, and point clouds, and ideally also graphs and trees. That would be amazing. It's on the roadmap, probably will come a little bit later in the year. And the other big thing that we're working on is scaling up Ludwig so that it's really easy to work with really big data sets, in particular data sets that are on like distributed data sources, like for instance on HDFS, or they are on S3. And the reason for that is that the strength and at the same time the limitation of Ludwig at the moment is that it works with these CSV files as input. And that's a strength because it's really intuitive and really easy to use for people. If they have a CSV on their laptop, they can train a model on their laptop. They don't need to go online and train in a distributed way. But actually, if you have a big amount of data that doesn't fit in your laptop, then how you're going to do that? So at the moment, Ludwig has this limitation that you basically cannot do that. But we are working on this integration with Petastorm, which is an open source project that Uber has released recently that allows you to interact and ingest data from HDFS, NS3, and these kind of sources in Apache Parquet format. And that will allow the training of Ludwig models on potentially petabytes of data. And that's the main direction that we are planning on expanding Ludwig in the near future.
Well, Piero, it's an awesome project, and it sounds like an incredible thing that's been missing for a long time. So I look forward to seeing where it goes. So if you want to find out more information, all you got to do is search for Ludwig, Piero Molino. It's spelled exactly the way it sounds. We don't have yet the InfoQ video posted from the Talk AQ on AI, but that'll be coming out soon. I know there's a blog post on Uber about Ludwig, and then you've got your personal website that is Wonderlust, spelled W4NDERLU.st, so Wonderlust.st, and then a 4 after the W, so you can get to the website and then look for Ludwig.ai for the actual website. Piero, thank you so much for joining us on the podcast. I can't wait to see where the project goes.
It was great. Thank you so much, Wes.
Wondering what's the current state of the DevOps and cloud computing space? Where are Kubernetes, chaos engineering, and AI ops in terms of adoption? Read the InfoQ Trends reports to find out about this and much more in less than 11 minutes. Check it out at infoq.link/DevOps-Trends-2019. We'll include the link in the podcast description as well.